Hello student, welcome back. It is lecture 1, module 3, Microcontroller and Embedded System. Sangita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Now this is module 3. This module consists of 8051 assembly language programming tools. In the previous class, we have studied 8051 microcontroller instruction set and addressing modes. Now in this lecture and onwards in module 3, we will study in details about the programming structure, assembly language program of 8051 and in detail. Before going into the detail of 8051 microcontroller assembly language and programming, let us get a brief idea about programming language in general, specific to microcontrollers and also type of programming languages. What is programming language? Programming is, in the sense of microcontrollers, means writing a sequence of instructions that are executed by the processor in a particular order to perform a particular task. Programming also involves debugging, troubleshooting of instruction sequence to make sure that the desired task is performed. Like any language, programming language have certain words, programmer and rules. Some grammar, syntax also there. There are 3 types of programming languages. These levels are based on how closely the statements in the language resemble the operation and task performed by the microcontroller. The 3 levels of programming languages are machine language, assembly language, high-level language. Now this is shown here, high-level language. From the point of speed, it is excellent, high speed, then assembly language, then machine language. But in case of ease of implementation, flexibility and portability, obviously machine language, then assembly language, then high-level language. Machine language. In machine language or machine code, the instructions are written only in binary pattern, that is the combination of zeros and ones, which are stored in high or low voltage levels. This is the lowest level of programming language and is the language that a microcontroller or microprocessor actually understands. Assembly language. The next level of programming language is the assembly language. Since machine language or code involves all the instructions in ones and zeros, it is very difficult for humans to program using it. Assembly language is a pseudo-English representation of the machine language. The 8051 microcontroller assembly language is a combination of English-like words, mnemonics and hexadecimal codes. It is also a low-level language and requires extensive understanding of the architecture of the microcontroller. High-level language. The name high-level language means that you need not worry about the architecture or other internal detail of microcontroller, and they use words and statements that are easily understood by humans. Few examples of high-level languages are BASIC, C, Pascal, C++, Java, etc. A program called compiler will convert the program written in high-level language to machine-level language. Why assembly language? Although high-level languages are easy to understand and work with, the following reasons points are the advantage of assembly language. The program written in assembly language gets executed faster and they occupy less memory. With the help of assembly language, you can directly exploit all features of a microcontroller. Using assembly language, you can have direct and accurate control of all the microcontroller resources like IO port, RAM, SFR, etc. Compared to high-level language, assembly language has less rules and restrictions. Structure of the 8051 microcontroller assembly language. The structure or syntax of the 8051 microcontroller assembly language is discussed here. Each line or statement of the assembly language program of 8051 microcontroller consists of three fields: level, instruction, comments. The arrangement of the fields or the order in which they appear is shown here. Level, then instruction, then comments. The brackets for the level and comments mean that these fields are optional and may not be used in all statements in a program. Before seeing about the three fields, let us first see an example how the typical statement or line in an 8051 microcontroller assembly language looks like. Test level, move A, 24H, semicolon. This is a simple comment. In the first statement, the test label is the name of the label. Move A, 24H is the instruction, and this is a sample comment, is a comment line. Therefore, test label is a label, move A, 24H instruction, and the rest is comment, and therefore comment will not be processed. Label. The label is a program chosen name for a memory location or a statement in a program. The label part of the statement is optional, and if present, the label must be terminated with a colon. An important point to remember while selecting a name for the label is that they should reduce the need for documentation. Instruction. The instruction is the main part of the 8051 microcontroller assembly language programming, as it is responsible for the task performed by the microcontroller. Any instruction in the assembly language consists of two parts, opcode and operands. Like move A, 22H. Move is opcode, A, 22H is operand. Move 22H to accumulator. Therefore, destination operand is A and 22H is the source operand. The first part of the instruction is the opcode, which is the short for operational code, specifies the operation to be performed by the microcontroller. Opcodes in assembly language are called as mnemonics. Opcodes are in the binary format using machine language, while the mnemonic, which are equivalent to opcodes, are English-like statements. The second part of the instruction is called the operands, and it represents the data on which the operation is performed. There are two types of operands, the source operand and the destination operand. The source operand is the input of the operation, and the destination operand is where the result will be stored. Comments. The last part of the structure of the 8051 assembly language is the comments. Comments are statements included by the developer for easier understanding of the code and is used for proper documentation of the program. Comments are optional, and if used, they must begin with a semicolon or double slash depending on the assembler. The following statement will show a few possible ways of using label, instruction and comments. Level without instruction and comment. Level semicolon. Level with line with label and instruction. Level colon move A, 22H. Line with instruction and comment. Move A, 22H. Then semicolon, this is a comment line. Line with label and comment. Label colon semicolon, this is a comment line. Line only comment. Semicolon, this is a comment line. There are different structure it is showing over there. 8051 Microcontroller Assembly Language Directives. Assembly language directives are not the instruction to the microcontroller 8051 microcontroller assembler, even though they are written in the mnemonic field of the program. Assembly language directives are actually instruction to the assembler and directs the assembler program what to do during the process of assembling. The assembly language directives do not have any effect on the content of 8051 microcontroller memory except DB and DW directives. These directives are dependent on the assembler program, and in case of ASM51 assembler, the following are categories of directives. Assembler state control, ORG and using. Symbol definition, segment EQU, set, data, iData, xData, bit, code. Storage initialization, DS, DBIT, DB, DW. Program linkage, public, extern, name. Segment selection, PRSEG, CSEG, DSEG, ISEG, BSEG, XSEG. We will now see about few of the important and frequently used assembly language directives. ORG, set origin. The 8051 microcontroller assembly language program will start assembling from the program memory address 000H. This is also the address from which the 8051 microcontroller will start executing the code. In order, place the program and data anywhere with the address space of 8051 microcontroller. You can use the ORG directive. Example, ORG 000H. Comment is tells the assembler to assemble the next statement at 000H. ljump main, code memory at 000H, jump to main. ORG 00BH tells the assembler to assemble the next statement at 00BH. Main NOP, code memory at 00BH, main starts here. DB, define byte. The DB directive is used to define a byte type variable. Using this directive, you can define data in decimal, binary, hex or ASCII formats. There should be a suffix of B for binary, H for hex. The ASCII characters are placed in single quotation marks like string. Examples: ORG 00H, DB10, DB30H, DB string, DB 0000111B, DB1234H. So, DB10 indicates defined by 10 decimal and stored at 000H. DB30H defines defined by 30 hexa and stored at 001H. DB string defines string and stored 002H to 007H. DB 0000111B defined byte 00001111 in binary and stored at 0008H. DB1234H defined byte 34 in hexa decimal number and stored at 0009H. Only lower byte is accepted as DB can allocate only a byte of memory. So, we are concluding today's session up to this. In the next session, we will start from here. So, I am showing over there. It is the references, and thank you. We are ending today's session.